In this video, we are going to find integers a and b that are relatively prime such that a squared plus a equals b cubed plus b. Before we move on, don't forget to give a like, subscribe to our channel, and turn on post notifications. As we are looking for integers a and b that are relatively prime, which means they do not share any common prime factor, so in particular, we won't consider the cases when they are equal to 0. Now, for values of b that's negative, then the whole expression b cubed plus b will be negative. So, but for a squared plus a, the minimum value is actually this. I can say is a plus 1/2 all squared minus 1/4. So the minimum value is minus 1/4. And starting from b equals minus 1, as b decreases, the value of b cubed plus b decreases from minus 2 all the way down to negative infinity. So we can't have b to be negative, it can't be 0, so that means b is positive. For this, I'm going to divide into two cases. The first case is very simple, it's just when b equals 1. Then a squared plus a equals 2, and it's a quadratic, so a equals minus 2 or 1. And next for b equals 1, sorry, b is larger than 1. That's the major case. From this, I'll rewrite the right side as b times b squared plus 1 equals a squared plus a. Or I can say it's a times a plus 1. And we know b divides a times a plus 1. And since b is co-prime with a, that means b only divides a plus 1. And so I can let a equals, or a plus 1 equals k times b, some integer k, and so a equals kb minus 1. Now I'll put this back into the original equation, and I have kb minus 1 times this plus 1, so it's kb equals b times b squared plus 1. Since b is larger than 1, non-zero, I can cross out this b, and so I have k squared b minus k equals b squared plus 1. So k squared b minus b squared equals k plus 1. Then factorize, we have k squared minus b equals k plus 1. And so again, I can say that in particular, b divides k plus 1. Furthermore, I'm going to let k plus 1 to be equals to, say, a multiple of b, mb. So k equals mb minus 1, some integer m. At this point, I'll put this into the equation again. And now we have b times mb minus 1 all squared minus b equals mb minus 1 plus 1. Then I will divide both sides by b, just like what I did above. I have mb minus 1 all squared equals m plus b. So now I have on the left some expression that's of degree 4, and for at the right we have something expression of degree 1. So we might be able to do some bounding. Now I'm going to compare this mb minus 1 all squared with mb minus 1. So I'm actually asking the question whether x squared is always larger than or equal to x, or it might be sometimes smaller than or equal to that. Now, for this inequality, we try to solve it. So either it's less than or equal to 0, or it's larger than or equal to 1. Now, however, we know this x is actually an integer. If it's not an integer, then it's possible that x squared is less than x. Say, for example, x is 0.5. But when x is an integer, the fact that x is less than or equal to 0 or is larger than or equal to 1 actually covers all the possible integer cases. So that means given that mb minus 1 is an integer, I don't care it's positive or negative, it's always the square that's the larger expression. So that means mb minus 1 is less than or equal to m plus b. So then I can proceed like this, add 2 on both sides so that I can factorize the left, and I have m minus 1 all multiplied by b minus 1 is less than or equal to 2. So there are not many cases to consider. The first case would be that if this m minus 1 is non-negative, then that means the whole product as b has been assumed to be larger than 1 is non-negative. So given as non-negative and it's less than or equal to 2, so then there are very few cases. First case, if m is larger than or equal to 1, then either we have this, so then m equals 1, because b can't be 1, it's assumed to be larger than 1, or the product equals to 1, so then m equals 2 and then b equals 2. Or for the product equals to 2, then either m equals to 3 and b equals to 2, or m equals to 2 and b equals to 3. Now if m equals 1, then we can go back to the equation that mb minus 1 all squared equals m plus b. So b minus 1 all squared equals b plus 1. And solving, we have b equals to 0 or 3. Of course, we don't want the case 0. So that means b is either 2 or 3. If b equals to 2, then we have a squared plus a to be equal to a plus 2, and that's 10. Seems no solution. While for b equals 3, then a squared plus a is equal to 30. And so a equals minus 6 or 5, but a and b have to be co-prime, so we reject the minus 6. So we have a solution here, which is a equals 5 and b equals 3. So this is the case when m is larger than or equal to 1. For the other case, when m is less than or equal to 0, we can go back to the original equation and try to do some make use of some divisibility. At this point, I'm going to try to divide both sides by b and see the remainder, which means mod b. On the left, we have 1 congruent to m mod b, so that means m minus 1 has to be a multiple of b. Now, given that m minus 1 is a multiple of b, but m is not positive, so that means it seems to be a negative multiple of b. Now, notice that m plus b is already a non-negative number. So m on one hand is negative, but it can't be too far away from 0. Even it's still a negative number. So we can say that m is larger than or equal to minus b, and so m minus 1 is larger than or equal to minus b minus 1. And given that it's a multiple of b, so that means actually there's only one choice. Well, actually two, where m minus 1 can still be 0. Well, kind of a multiple of b, b because it's b times 0, or is exactly minus b. Now if m minus 1 equals 0, then we can reject it because that means m equals 1. But for the other case, that means m equals minus b plus 1. Then going back to the equation above, then we have minus b plus 1 all multiplied by b minus 1 all squared is equal to 1. So minus b squared plus b minus 1 all squared is equal to 1. Then from this we have b squared plus minus b plus 2 equals 0. Clearly no solution. Or b squared minus b equals 0. And that means b equal to 0 or 1. But this is under the first assumption in this solution that b has to be larger than 1. So that means for this part we have no solution. So altogether there are 3 solutions, which are when b equals 1, then it's minus 2 or 1 for a, and when b equals 3, a equals 5. So this is the final answer. Please feel free to share ideas in the comments. Thank you for watching. See you next time.